So let's talk about increasing, decreasing stuff. So this is now moving on to section 3.3. And I've really been using the words increasing and decreasing for a while now. I've been using the fact that when the derivative is greater than 0, this means f is increasing at x. So usually I'll put a little up arrow up and to the right to show it's increasing. If the derivative is less than 0, you know that that means f is decreasing at x. So I'm gonna put a little down arrow like that. And then obviously when it's equal to 0, that's when you have a horizontal tangent line, and that's now the critical value situation that we're talking about, right? So I think this is nothing new. And what we can do is we can talk about finding the or I guess there's a couple things we want to do. One thing we want to do is we want to find intervals of increase and decrease. And then the second thing that we want to do is we want to be able to classify critical points or critical numbers. Okay. So how do we do each of these? To find the intervals of increase and decrease, the way that I usually do this is I chop up my domain, into pieces separated by critical values. And then I'm going to find the sign of f prime on each piece. So I'm going to show you an example of that in a second. Okay. We do that for graphing a lot. So you know, that's kind of how I would handle that first part. For the second part, classifying critical points, this is what we call the first derivative test. And it's not called the first derivative test because it's the first test. It's called the first derivative test in reference to the first derivative. And I can really show you this pretty easily by drawing a bunch of pictures. So let me draw 4 pictures for you. These pictures are on the worksheet already, but I don't know. After looking at the number of views on the videos, I don't think all of us watch every video, and I want to at least summarize what they're talking about. So we're trying to classify critical values. And we know that C is the point where the derivative is 0 or it doesn't exist, meaning it has a corner or a cusp or something like that. If it goes from increasing and then to decreasing, that's when you have a maximum. If it goes from decreasing and then increasing, that's when you have a minimum. If it increases, hits 0 and then increases again, this situation is when you have neither a max nor a min. That's the x cubed situation that I was talking about earlier in class. It sort of increases and then it flattens out for a split second and then it increases some more. This is the x cubed situation. And then it could also sort of decrease, flatten out, and then decrease again. So it could go decrease, it could flatten out, and it could decrease again like that. And that would be an example of that would be y equal to negative x cubed, for example, because x cubed looks like this and negative x cubed looks like this. So it's just the exact opposite situation. Does that make sense for everybody? Is there any questions about that first derivative information? I feel like it's pretty obvious, I hope. So let's take a look at our 3.3 worksheet. There are those pictures that I told you about. I give an example. You know, what do you do? First, you find the critical values, and then you classify the critical values by, in this case, we use test points. So I take my domain of a polynomial is all real numbers. I have all real numbers here. But because my critical values are -1 and 3, I can divide my domain up into 3 pieces, from -infinity to -1, -1 to 3, 3 to positive infinity, like that. Then in this case, what I did was I used test points to figure out if it's increasing or decreasing within each subinterval here. Is there any questions about that? So in case it's not obvious, I don't know why I didn't label it here. Oh, I did. You have a max at -1 because it goes up and then comes down. You have a min at 3 because it goes down and then comes back up. Oh, sorry, Aaron, I just read your comment. I think that's exactly what I said. So you probably predicted what I was gonna write. Oh, so this is neither. They're both neither, sorry. I understand what you're saying. I didn't write the word neither. You weren't sure. This is neither as well. Some people say neither. Let me move this chat box up to where I can see it more easily. All right, cool. Any questions or other questions? Okay, great. So let's take a look at example 2. For example 2, it says use the first derivative test to find the location of all local extrema for this guy over here. In this case, we have fractional powers. So there are some of you students that I've been working with pretty extensively in regards to this fractional power thing. I want to give you an opportunity to show me that you learned it. So take a quick moment and calculate f prime for me. All right. So remember, we got to bring down the power. So 5 times 1/3 is 5/3. We got to subtract 1 from the exponent. 1/3 minus 1 is -2/3. That's going to be the first term. And for the second term, we bring down the power. That's another 5/3. And then I got to subtract 1 from the exponent. It's going to give me x to the 2/3. Is there any questions about that derivative? Now I want to factor this guy. So I don't know if I emphasized that when I was talking about over here, but we want to chop up the domain and separate it with critical values. In order to find the critical values, you really need to factor f prime. So we want to factor this guy. I see a common factor of 5/3, so I'll pull that out. And then what I'm going to do next is I'm going to pull out the smaller of the two exponents. So the smaller one is going to be the negative 2/3 power. So I'm going to pull out that as a common factor, x to the negative 2/3. And you could see that this guy is exactly the same as this first term. So that when I factor that out, that's going to be a 1. But when we look at the rest of it is going to be x to some power. And then the question is, what should the power of this be so that when I distribute, I'm going to get a 2/3? And the answer to that is, if I make this a 4/3 right here, 2/3 plus 4/3 is 2/3. So when I distribute, I do get this. But now I can see that my derivative has been factored. Okay. So when I calculate the critical values, I have 0 is equal to 5/3. I'm going to have c to the negative 2/3. And they're going to have 1 minus c to the 4/3. Okay. Now, this guy right here is in the denominator because of the negative exponent. And so whenever you have something in the denominator, you can't have that denominator be 0. So this tells us that c equal to 0 is a critical number. For the next guy, we need to check where the other term is going to be 0. So I don't know if that needs to be all in red, but let's talk about the next term. So now we also want to set 1 minus c to the 4/3 power equal to 0. And that's going to be saying that's the same thing as saying I have c to the 4/3 is equal to 1. And what I want to bring to your attention is that we have this even power here. So that even power, notice even power. Okay. So why do I ask you to notice that even power? Because I think most of you, if I asked you what C would be, most of you would say 1. And 1 is correct because 1 to any power is going to give you a 1, right? But I want you to notice that C equal to negative 1 is also a critical value. Because the cube root of negative 1 is negative 1. So if you did negative 1 to the 1/3 power, and then you raise that to the 4th power, that's really going to be equal to negative 1 to the 4th power, which is still equal to 1. So in actual fact, from this equation, we get 2 critical values. We get C is equal to negative 1 and C is equal to 1. Okay. So really, we have 3 critical values, C equal to 0. I don't know why that's in red. C equal to negative 1 and C equal to 1. Does anybody have any questions on them? Make that blue, I guess. How did you get negative 1 and 1? I think it should be obvious how you get 1, right? 1 to any power is 1 to any power is 1. Does that make sense? So this guy should be obvious. And then if I think about, I'm solving this equation, right? So you know how when you take a x squared equal to 1, sometimes you could take the square root of both sides, then you would get x is equal to plus or minus 1. Well, it's the same thing if you do the fourth root. So if I did the fourth root, I would still get, I mean, if I raised to the fourth power, I would still get the same thing, right? So the way that I'm thinking of it is, I know that -1 to the 1/3 power is still -1. And then if I raise it to the fourth power, I still get 1. That means -1 is also a solution to this equation. So yeah, okay. Like when you have even powers, you got to worry about the positive and the negative square root. So we have our critical values. So what we're going to do is we're going to come over here, and I want to teach you a couple methods of how to really chop things up. But the first method is using test points. So I'm going to label my critical values, which would be, here's a 0, here's a 1, and here's a -1, like this. And then what we can do is we could choose some test points. So we could choose like a -2 and calculate what f prime of -2 is. We could choose like 1/2 and calculate what f prime of -1/2 is. We could choose a test point in here of 1/2 and do what is f prime of 1/2. And then finally, we could choose something bigger here, like 2, and calculate what the sign of each of those things is. So I think you can just take your calculator and plug in numbers here. So I guess I'll leave it in green. We could have like f of -2 is equal to 5/2 times -2 to the -2/3 times 1 minus -2 to the 4/3, like this. And then you could calculate what number that is using your calculator. We could do the same thing with 1/2. F of -1/2, 5/2, -1/2 to the -2/3, 1 minus -1/2 to the 4/3. All you care about is the sign. We don't care about the actual number. You just care if it's positive or negative. Okay. We could do the same thing with f of 1/2 and f of 2. So let's copy this down. Just make all those -1/2s positive 1/2. And then we can copy this down and make all those -2s positive 2s. Okay. So why don't we take a second to do this? All I care about is the sign. So let's try to figure that out. So you can take your calculator and do it. just so you guys know, a lot of times to get a negative number, if you want a negative number, there's oftentimes a button that looks like this that gives you a negative number. And if you see a button that looks like this, that's usually an exponent. So if I have -2 to the -2/3, I get a negative number, right? So this part right here is negative, so it's almost like I get a positive number and then a negative number, because 5/2 is positive. And then I can really do 1 minus parentheses, -2, close parentheses, to the 4/3. And then this part also gives me a negative number. Since I only care about this sign, I hope you guys can see that I have a positive number times a negative number times a negative number gives me a positive number. So this guy is increasing. And then I want to do the same with the other guys. So again, this part here is positive. I can look at the, you can really enter the whole thing all at once if you want. Or I could do, hold on 1 second, let me check one thing. Shoot, I messed up. Sorry. I didn't, when I did on my calculator, I didn't put the parentheses right here. So this middle part is positive because you got the square things. So that's gonna be positive. It's my bad. So this is negative here. I wish I could show you my calculator. Can you see? You can't see it. Make sure you put parentheses around this thing before you raise it to the power. I didn't put parentheses around there and I messed it up. So for this second part here, it's going to be negative point, parentheses, -0.5, close parentheses, raised to the -2 divided by 3. This guy is also a positive number. And then when you take this last part, that's going to be 1 minus parentheses -0.5 raised to the 4/3 power. And I get a positive number, right? So positive times positive times positive is positive. So this guy was decreasing. This guy was increasing. And we do the same thing for the last two. Okay, so I think if you do the last two, you're going to get a positive number here, and you're going to get a negative number there. So this part here is going to be your maximum. I'm sorry, your minimum. So we have a min here, and we have a max here. That would be our answer.